Okay, let's look at an example that will hopefully work towards convincing you that you should use the Leibniz notation rather than the Newton notation. Let's take a function for which the amount of work that's required is just a little bit too large to manage to keep in your head all at once. So we have something like f of x is equal to what would be a nice dreadful function to think about. Let's begin with tan to the fourth of e to the 3x to the fifth times ln of 4x plus sine squared of x cubed minus 2x plus 1. Alright, and this one has a few derivatives that we don't yet know. We'll pick them up in the next couple of sections, but the derivative of e to the x is e to the x, and the derivative of ln of x is 1 over x. And we are definitely not going to be worried about whether or not any of this is defined at any given point in time, because that's just way too much work. So, if I wanted to find the derivative of this using the Newton notation just using nothing but primes, takes me from here to the answer in a single step. And that's tricky. If you mess up at any point, it can really cause quite a chain reaction, or it can create a situation where it's entirely unclear to the reader, to the marker, what is going on. So let's try to take the derivative of both sides with respect to x. Left hand side is easy, that one I can just write as f prime of x. Then I look at what's left. I begin with the fact that this is tan to the fourth, so it's box to the fourth. So I want to take the derivative of tan to the fourth of, and I ought to write this entire thing, but no one's going to gain anything from me doing that. So I just write it as blah. This is a technical mathematical term. You're allowed to use it in cases of emergency, and this is certainly one of those. So I'm taking the derivative of box to the fourth with respect to box. And that's going to give me, for my next step, 4 box cubed. Next, since I took the derivative with respect to tan, and that's not the d by dx that I should have at the end, I now have to take its derivative. The derivative of tan of e to the whole bunch of stuff, well, I can look at this as tangent of something, and so I can take the derivative of it with respect to e to the whole bunch of stuff, and when I do that, the derivative is going to be secant squared of box. Obviously, in my proper solutions that I write up for an assignment, I won't have these little bits, but they do give you exactly what you're going to have in your next step. Now I can take the derivative of e to the whole thing, e to the 3x to the fifth ln of some stuff. I can look at this as e to some power, and so I can take the derivative with respect to that power. I then need to take the derivative of this, but notice this is a product, so I multiply by something that is going to begin with a product, but before I do, let me just write this as e to the box. That's the derivative. And so, to take the derivative of the exponent, I need to use the product rule. So I need to multiply by the derivative of 3x to the fifth with respect to x times ln of blah. That one's just, that bit is done. Very strange. Plus 3x to the fifth times the derivative of ln of 4x plus a bunch of stuff with respect to, well, I can look at this as just ln of that thing. So its derivative will be 1 over x as soon as I take the derivative with respect to the thing on the inside, times 4x plus some stuff. I need to take the derivative of the 4x by itself, plus the derivative of sine squared of x cubed minus 2x plus 1. I go back to how I started things out. This is just something squared, and so I take its derivative with respect to sine of x cubed minus 2x plus 1, and so the derivative will be 2 times box. I multiply this by, I'm already into the third line of the equation, I multiply it by the derivative of sine of x cubed minus 2x plus 1. This is now just sine of some object. I take the derivative with respect to that very bizarre looking angle, and then I can simply take the derivative of that, because it's a polynomial, with respect to x, close up my brackets. Derivative of sine of box is cosine of box, and now I can just write down the solution, or the answer. I can write it immediately without having to spend any time thinking. This is 4 times box cubed. Box is right here. All I have to do is copy it down. 4 tan of blah times secant squared of blah times e to the 3x to the 5th ln of blah times open bracket. The derivative of 3x to the 5th is going to be 15x to the 4th ln of something ugly plus 3x to the 5th times 1 over, oops, sorry about that one, not 1 over x, but 1 over box. So the derivative will give us 1 over 4x plus blah times another open bracket. The derivative of 4x is 4. Derivative of box squared is 2 times box. Derivative of sine is cosine. And the derivative of the polynomial is 3x squared minus 2, close bracket, close bracket, close bracket, and believe it or not, we're done. If you can manage to go from here to here in a single step consistently all the time, that's pretty impressive. But I want to see this. I want to see the justification so that I can believe that you can go from here to here in a way that is reliable.